Somebody just asked me to record. I'm going to do that. And okay, good. Properties, that's share. Okay, so this is a logarithm. Does anybody remember what we call this ln? Anybody remember what we call it? Oops, you just got this big head in front of you. Let me change that out. You look at my big ugly head. There we go. Anybody remember what we call ln? ln has a name. Ellen, get it? LN, Ellen? No, that's not its name. I just thought of that. That's kind of punny. Haha. All right. ln is the natural logarithm. Natural logarithm, ln. All right. But it's a logarithm. So I want to use the product property here because I have a product as my argument, and I want to expand this logarithm. So that means this is equal to ln x plus ln y. Everybody see how I use the product property there to expand it? Okay, well, what about this one? I think this argument here looks to me like a quotient, right? It's a division thing happening here. So I'm guessing that this would be equal to log 8 minus log 7. Log of the numerator minus the log of the denominator. Am I right? I'm sure I'm right. Oh, yes. Well, it's not. Its answer is C. We're not even going to bother with that. Okay. Wow. Give this one a try. Look at your properties of logarithms. Remember, the properties of logarithms, which are behind me right here, I hope you can still see them. They're equations. That means they go both ways. We can look at it both ways. So I want to condense this into one logarithm. Jordan, can you help me?
Yeah. I got log 11 over 8.
And that is correct. Log 11 over 8. Log m minus log n is the same thing as log m divided by n. Is everybody okay with that? Are we okay? Pretty clear? Okay, how about, oh no. We'll do this one together here. Okay. I want to condense this logarithm. Okay. Which property do you think I should use? 1, 2, or 3 here? Which property? 1, 2, or 3? Brooklyn, what do you think? 3. Brooklyn's holding up 3 fingers. Yeah. That's right. I'm going to use it. So Brooklyn, then do you know how I would do it? What do you think? What's it going to look like?
I think it would be ln a to the 6th.
Excellent. Outstanding. That's exactly what that would be. Whoops, I just stopped sharing. Why did I do that? I don't know, push the wrong button. There we go, back again. Okay. Everybody okay with that? Is that pretty clear? Is there a question on it? Anybody want to ask me a question about that? Yes, Mia, please.
I don't understand.
You don't understand. Good. That's good. Okay. Do you understand that the third property of logarithms is log m to the r is equal to r times log m? Are you okay with that? R log m. So that is the same thing as log, well, I'm going to put ln, m to the r, which is ln a to the sixth. Do you see it?
Yes, thank you.
You're welcome. Everybody see that? Pretty good? Okay. Well, so we're going to do a little bit more work now on expanding logarithms, okay? So we'll work some of these together. Now, I have here a single log. This is a log base 2, and it's one log, and it has a rather complex argument. Everybody agree that that's a rather complex argument? I say it's a rather complex argument. Now, one thing I want to point out here that's kind of a little bit of a tangent is this right here. A lot of times when you see a logarithm, you're also going to see that they specify what the domain of the logarithm is. Now, we could have found that out by looking at the argument of the logarithm. The argument is x squared times the cube root of x minus 1. And we know that the argument of a logarithm has to be greater than 0. So it has to be greater than 0. Why couldn't it be a no? Okay, so so this piece of the product has to be greater than 0. And this piece of the product has to also be greater than 0, which means that, you know what? I'm not going to go there right now. That's going to get us too distracted. Forget this right now. We'll deal with that later. We'll deal with that later. But you will see this telling you what the domain is going to be. So I want to write this as a sum of logarithms. I want to expand it. Can you see that I have a product here, x squared times the cube root of x minus 1? Can you see that? Yes? Okay, so I'm going to start with my property number 1. And I'm going to go log base 2 x squared plus log base 2 cube root of x minus 1. So this was property P. Property number 1. Well, I'm not done. I want to expand it out as far as I can. So I'm looking at this logarithm right here, and I can think of, well, I'm going to use property number 3 and expand that into 2 log base 2 of x. Plus, now I have a radical sign here, but I'm going to change that. I'm going to change it to log base 2 of x minus 1 to the 1/3 power. I'm changing my radical sign into a fractional exponent. Is everybody okay with what I just did there? Is there a question about it?
Yeah, I have a question about that.
Please.
Did you use a property for that, or were you just making it an exponent instead of a square root?
I was just making an exponent instead of a radical. And the reason I did that, Brooklyn, is because I want to use property number 3 again. This one here is as expanded out as it's going to get, log base 2 of x. But this now is plus 1/3 log base 2 of x minus 1. Do you see I used property 3 to do that? So I have completely expanded this into being a sum of logarithms. So let's just pause for a question. Somebody want me to repeat something here? No, we're doing okay? Okay. Hang on 1 second here. Okay. Yes, I am. Well, here I want to expand it again. I'm taking a single logarithm and I want to expand it. Now, this is important to point out. This expression right here is not log base 6 over log base 6. I'm not distributing the log to the top and the bottom. I'm not doing that. That is a very common mistake. Don't do it. I want to turn a single logarithm into an expanded logarithm. And in this case, they're telling me it's going to be a difference. So I know that that log m divided by n is equal to log m minus log n. So that's where I'm going to start. I'm going to say this is my m, this is my n. So I have log base 6 of x to the 4th minus log base 6 of x squared plus 3 squared. So that's how I would start this. And then I want to expand it some more because I have these powers here. I'd like to get rid of those powers so I can make this first expression into 4 log base 6 of x minus 2 log base 6 of x squared plus 3. Okay, so again, another thing I want to point out that is a very common mistake is looking at this right here, this x squared plus 3. You might think that you can use the power rule again, but you can't, because this x squared plus 3, okay, everybody unmute, everybody unmute. Everybody. Now I can't talk. X squared plus 3 is a what?
Binomial.
Okay, that's good. All right, you can mute now if you want. All right, it's a binomial. So I can't just apply the property to this. There is no property over here, right? So don't make that mistake. I can definitely use it with this because that is the exponent for the whole argument. This x squared plus 3 is the argument. I can't just use the power property on just part of it. I have to use it on the whole binomial. Okay. Let me see. Yeah, okay, we got some. Okay, so we'll do one more together, and then we're gonna do it. Then we're gonna give you some problems to do. Whoa, baby, this is an interesting problem. All right, so let's use a magic bowl here. Maria, which property do you think I should use to start to expand this guy right here?
The quotient property.
I think I should use the quotient property to start, right? So that's going to be what? Ln what?
Ln x to the cube root of x minus 2.
Well, no, it's ln x cubed. It's not a cube root.
Oh, I thought it was with the, okay.
Yeah, but that's
then,
okay.
Yeah, the square root of x minus 3.
2.
Oh, minus 2. And then that's minus ln and then x plus 1 squared.
X plus 1 squared. Everybody okay with that? Okay, so far so good. Now I'm looking at it, I'm saying, no, I can still do some work on this. So let's look at the first term of that difference right there. Kristen, what can I do to simplify this part right here, the first part?
One of the properties.
Yep, which one? 1, 2, or 3?
Let me see. Would it be 3?
It's going to be 3 in a minute,
Okay.
but not yet.
Then 1?
Yes, I got to do 1 because I have a product here. Do you see it?
Yes, yeah.
Okay, so what is this going to look like if I expand it using the product property? Tell me.
It's gonna look like log x to the 3rd,
Good.
and then log negative 2.
What?
Oh, x minus 2.
Square root of.
Okay, square root of x minus 2. Yeah.
Now, what symbol goes in here between those two?
The plus sign.
Plus sign. Very good. Very good. You don't want to put a multiplication sign in there. So that's good. Okay, so we're making some progress here. And then what about this next one here? Isabella A, can you help me? What can I expand this one over here at all? Did you get kicked out, Isabella? She might have. She said she was having internet issues, so we'll call somebody else. Jordan, can you help me with this one here?
Yeah.
What property should I use?
I don't remember the name of it, but it was the third property.
The third one, yeah. So we'll call it property 3. That's okay. It's called the power property. So what does it look like?
This changes it to 2 ln parentheses x plus 1 parentheses.
Yeah, you guys are really getting onto this quickly. That's good. Okay. So now I'm looking at it again, still, and I want to say, well, is there anything else I can still do? Take it apart piece by piece here. So Sydney, is there anything I can do to this first piece here to expand it a little bit more?
I don't really know what property you use, but could you put the 3 in front?
Yes, that's the power property because the 3 is like a power of x. So that'd be 3 ln x. That's very good. And radical signs, I want to get rid of that. So I'm going to change that to log x minus 2 to the 1/2 power. All right. So, Jordan, again, is there anything I can do to simplify this second piece right here?
Could we do the power property again?
I think so. So I'll put the 1/2 in the front and I'll erase it from here. Does that work for you?
Yeah.
Okay, works for me too. And Mia, on this last piece here, is there anything I can do to expand that one?
No.
That's right. No, that's done. That's as expanded as that's going to get. Well, I think that's my answer right here, ladies. I've expanded this guy as much as I possibly can.
Sorry, I have a question.
Great, Mary Rose, please.
I'm just kind of confused where the log came from.
Oh, with the log, this log here,
Yeah.
it came from. It came from.
This local access message is brought to you by Uber Eats.
Came from here. Not supposed to be there. It's supposed to be an LN. I was bad. I was bad. I was a bad person. No, I'm not. That better? That's good? Okay. All right, let's go ahead, do this problem. I want it expanded as much as it can possibly be. Okie dokie. Let's see who gets to give us the answer. No, Isabella A fell out of the system here. Crystal, can you help me?
Possibly. So, first I did ln x to the third minus ln x to the sixth.
That's a good place to start.
Okay.
Ln y to the 6th, but
Oh
that's,
yeah, that's what I meant.
okay.
And then, so here's where I went wrong. So then I did 3ln, then I did like the power one. So I did 3ln x minus 6ln y.
Yeah.
And that's where I can't go any further. That's where I got stuck.
And so why do you think you're stuck? Why do you not think that that's just the answer?
Oh. I don't know, because the other one was a lot more complicated.
Well, I'm looking at this one. I'm thinking this one looks pretty good. Everybody agree this one looks pretty good? I think this one looks pretty good. Crystal, you gotta, these boys are gonna just walk all over you. No, we're not gonna allow that. No, and yeah, just come on. Like, I think it's this. Bup, 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 bup. You don't like it? Well, okay, but I mean, come on, like, confidence here. Okay, good. Everybody see that one? Any questions? No questions. Okay, good. Well, you guys are really grabbing this here. Oh, wow. Try this one. This one's a little tricky. This one's a little tricky. We're ready? Ready? Ready to try it? Okay, Magic Bowl. Magic Bowl is asking Juji, who had to go someplace. That's fine. So it's asking now, Maria.
So I was a little stuck on the problem. So my first step was to do property 3. And so I got 4ln and then in parentheses x6 over y.
That's good. I think that's a good first start. Then what'd you do?
Well, I think I need to use property 2.
Uh-huh.
And then I just wasn't sure if it would give me 4ln x to the 6 and then minus 4ln y.
That's exactly what it's going to give you. Okay, now, but let's explain why, because this is a little bit tricky. Okay, so this is definitely the right answer. But I want you to look at this problem right here and realize this is saying 4 times this logarithm. Everybody see that? Yes? So this is 4 times, and then I'm going to go ln x to the 6th minus 4 ln y. Everybody see that? Right? And so, Maria, what you did is you distributed the 4. Right? So it becomes 4 ln x to the 6th minus 4 ln y. Everybody see that? Yes, but there's still one more thing you can do, Maria. Go ahead.
I could use the third property, and then would I have to multiply the 4 and the 6? Then
Yes,
that would
you would.
be 24 ln x minus 4 ln y.
Very good. So this is the fully expanded answer. So let's just stop there. Is there a question? Everybody good with that? Good. Okay. Let's see. Press go to do some more. Here you go. That's a z to z squared, okay? And remember, like, change the radical signs to fractional exponents. Otherwise, you're going to forget to use a property 3. Alex, what do you think?
Honestly, this is the one that really, like, I didn't really know how to start it. Because I don't know what to do first.
Well, so there's a product here. Can you see the product?
Mm-hmm.
Okay, so
Oh, now I can.
now you can see it. That's all you need.
Yes.
Huh? Okay, so tell me what to do.
Is it, why am I now forgetting to do this? Oh, sorry. You just write log z squared plus log square root of x.
Log square root of x.
Yeah.
Yeah. Okay. Then what?
Maybe the power property for the first one.
Go for it. Tell me.
And that would be 2 log z.
Uh-huh.
And then the next part for the square root, is it, I know you have to, like, I know for the last one, or one of them, you put like 1/3 on the outside. I know this would probably be like 1/2 on the
That's
outside
exactly
of
right.
x.
That's exactly right. So this is log x to the 1/2. The square root is the same thing as to the 1/2 power. Okay, so then what?
And then power property for that one, so it would be 1/2 log x.
Very good. Very good. How are we feeling about this? Pretty decent? Pretty good? All right. So next class, we're going to do condensing logarithms. We figured out how to expand them. We're going to do condensing them. But before you go, I have to talk about something. So I've had a little bit of an issue with unauthorized collaboration on tests. It's not a big issue, but there's a very thin line between asking your friends for help understanding a concept and asking your friends for help understanding a concept that happens to be on a test. Okay, so because I want you to talk to each other and help each other, you know. So if somebody says, you know, I don't remember how to do property number 1 of logarithms, I want you to be able to talk about that. But if there's a test involved and say, well, I don't know how to do property 1 on logarithms, you know, on this problem, that's kind of crossing the line a little bit. You follow what I'm saying here? Okay. Sometimes it's hard to tell where that line is. But if you accidentally step over the line, that gets you into a world of hurt. And maybe not so much at NDA, you know, because we have an honor code and we have a whole system and we're relatively forgiving. But you know, my brother teaches at the University of North Carolina, right? My brother teaches at the University of North Carolina, and he's a professor there. And when he sees something like that, that is like, you know, kind of close to or crossing the line, he just turns it over to whatever their judicial committee is, and then he never sees the student again. They're gone, you know. Now, whether they're just out of his class or whether they're expelled from the university or whatever it is, they're very unforgiving. And you are out of there and your tuition stays, okay? You don't get a refund for getting thrown out, okay? So you got to be very careful. So the best thing to do is like what we had years ago, which we should probably pick it up again as like a major campaign of, you know, hashtag ATT, hashtag ask the teacher. If you have any question, just ask the teacher. You know, is it okay if I ask one of my classmates about this? Or you can ask them and say, I don't understand this, and see what they'll do, right? But it has come up a couple times, not in this class, but it is an issue. So I'm just raising it to you so that you're aware and you just don't get yourself in trouble. Just ask the teacher and you're going to be fine. That okay? Are we clear? Okay, great. Go, you have 5 minutes extra for your nap. All right, we'll see you later.
Thank you.
Thank you.